Let us quickly go through binary operations. So, to start with, what are binary operations? So, just from the word bi means two. So, when we talk about binary operations, this is where we operate on two things. Yeah, and binary operations, they are represented by an asterisk. Is it asterisk? Yeah, whatever it is, they are represented by this star. So we operate on one thing and the other thing. Hence, by means two. Yeah. So before we even get started, jumping into examples, let's quickly look at the rules of binary operations. So what are some of the rules which you should just definitely know? Let's start with a very baby rule. This is the closure rule. So what does the closure rule states? It states, how can I even put this in simple terms? So the closure rule states that when you operate on two things, the final result should be like the two things you operated on. Yeah, so let me just give you this example so that you get it very well. So let's say you have a chicken which is right there, and then I also have another chicken. I'm very bad at drawing. Okay, so this is the other chicken. It's very ugly because it smells. Yeah, so we have these two. So now here I want to understand the closure. So if these two chickens they do their things and then they even lay eggs, is it possible that we're going to have a dog as an end product? Logically speaking, no. Two chickens will give us another set of chickens. If dogs mate, they are going to give us dogs. So now this is where the closure rule is coming from. If we have, let's say, real numbers, so this is the symbol for real numbers. Oh, sorry, natural numbers. If we say 2, we operate it with 3. This is a natural number, this is also a natural number. Then the final answer should be a natural number, meaning the closure rule is true. Are you getting that? Yeah, so this is what the closure rule states in very simple terms without being technical. Real number plus natural number plus natural number, it gives us another natural number. 5 is the natural number. So in this case, addition is proven to be real for the closure. For the closure rule, it agrees. So quickly, let's just look at the other one. Let's say we have 2. Let's say 2 minus. Yeah, so let's subtract this. Let's say 2 minus 3. So this is a natural number, this is also a natural number, but -1 is not a natural number. This one is an integer. So in this case, the closure rule is not true when we're subtracting. Yeah. So this is the basic thing of the closure rule. If we have natural numbers, we have whole numbers, yeah, all these kind of numbers, real numbers. So I hope you are familiar with the types of numbers. Yeah, so that's the closure rule. We shouldn't waste time here. And then the second rule now, where things get interesting. So rule number 2, it is the commutative. The commutative law. So we actually looked at this even on set theory. the laws of set algebra. So the commutative law simply talks about if we have an operation, let's say for example 2 times 3. If we change the position, are we going to get the same answer? So 2 times 3 is 6. 3 times 2 is 6. So meaning the commutative law is true for multiplication. Yeah, we get 6, we get 6. Yeah, so changing the position doesn't really change anything. That is the commutative law. So and in binary language, we say if we have a binary operation A star B, this will just be the same as B star A. Even if we start with B first and then we write A later, this should be just the same. Yeah, A star B is equal to B star A. Yeah, so nothing much special here. I'm sure you've gotten it. So let's go to rule number 3. So things are getting more interesting. Let's look at the associative law. Again, we looked at this under set theory. So if we have A star B star C, and then we can put this. So A star B star C, here now we're just trying to look if we operate in different ways. Like we start with A star B, will it give us the same as if we operate it like this? So remember, when you have brackets, it means that's where you start from. So the associative law simply states that even if you arrange the operation like this, it will give you the same result like that. Yeah, so this is the associative law. So just stick around, we're going to have some practice questions. So this is the associative law. Nothing much to think of here. What can we talk about? Yeah, just this. So just remember, this is the associative law. We put one group in brackets and another group in the other set of brackets. And then now we come to this troublesome law, which is the identity. So is this rule number 4? I hope you're writing in your book. If you're not writing, then I don't know how you really learn mathematics. You have to be solving. So the identity law, this one, it states that if we have a certain number, let's call it A, if we operate it with another certain number, what we get, it is still A. Yeah, so meaning E is the identity. I hope you have heard that. Yeah, so for example, if we have 2 times 1, it is just 2. If we have 3 times 1, it is just 3. Whatever we multiply, meaning 1 is an identity for multiplication. For addition, the identity is 0. If we have 2 plus 0, you still remain with 2. 3 plus 0 is still 3. So this is the identity law. The identity law just says A star E is just equal to A. So it is the same even if you start with E star A. You just end up with A. This is the identity law. You can't afford to forget this. And then the last one, it is the inverse property, the inverse law. So the inverse law, it relies much on the identity law. So this is where we operate any 2 random numbers. Let's say A star B. When we operate on these 2, we're getting an identity. This is the inverse. You just operate on 2 numbers, you get an identity. Yeah, so here again, even if we start with B B star A, it should still give us an identity. Yeah, so this is the identity law. So for example, let's say we have 2 plus something. Remember, for addition, the identity is 0, because anything plus 0, it is just 0. Yeah, so just a quick recap. Even if you already understood, if we say 4 plus 0, you still remain with 4, meaning this 0 is an identity. So now this is the identity we are having. So now, like, what is the inverse of 2? The inverse of 2 is just any number whereby if you add it to 2, you are going to get 0, and that number is negative 2. If you say 2 plus negative 2, you get 0. Whew. So I'm sure even yourself you have felt it, like, okay, these two rules are something. Yeah, so this is about the binary operations. So this is the commutative law, and this is the associative. Yeah, so now are you ready for practice questions? If you are ready, you can like the video so that the questions will come. Have you done so? Okay, so let's get started. Okay, so this is what we'll start with. So given that a function is defined by, let's say a function is defined by a star b is equal to a plus b minus ab, and then they ask us to find 2 star 3. So you know what a binary operation simply means here. So when they tell us to find 2 star 3, so the first number which is listed, it means it will take up wherever there is a, and then the other one wherever there is b, meaning that's where we put 3. Yeah, so this is simple and straightforward. You have seen, okay? So we say a. Oh, what do you want to say a? So we want to find 2 star 3. So while there is a, we're putting what? 2. Plus, while there is b, we put 3. Minus, while there is a, we put 2. While there is b, we put 3. Yeah, so from here we say 2 plus 3, that's 5, minus this is supposed to be 3, minus 2 times 3 is 6, meaning our answer is negative 1. So therefore 2 star 3 is negative 1. We have calculated just like that. So let's go to question B. We calculate negative 4 star 2 star 3. So remember, binary, we just deal with 2 things first. So we're going to start with negative 4 star 2. So this means that wherever there is a, we put negative 4. Negative 4 like that, where there is a, plus 2 is positive, plus 2, minus a, we are putting 4 where there is a, negative 4, and then b, it is 2. So negative 4 plus 2, negative 2. So this is negative 2 minus negative 4 times 2, it's negative 8. So this is negative 2. Negative and negative is positive. So here we have positive 6. So this means that we have done negative 4 star 2. So now we're remaining with the last part, star 3. So here we just continue from where we ended. So the final answer is 6. You have seen it. So the final answer, we just say star 3. You see, huh? So here it means all this now star 3. That's what we're doing here. We have done 4 star 2. Now let's do star 3. So this negative 4 star 2, it is 6 according to the calculation we've done. So here what's next is, so this means that 6 is our A, 3 is our B. Yeah, so while there's A, we put 6 plus, while there's B here, while there's B, we put 3. So minus A is 6 and then B is 3. So this is 9 minus 18. Yeah, so 9 minus 18 is negative 9. So this is how you find these 2 questions. So I hope you followed. Wherever you are not clear, you can always remember to just screenshot that part and then you send to my WhatsApp line. So now we have done the first 2, this, that. So now let us try to determine, is star commutative, meaning is this operation commutative? So for us to know whether it's commutative or not, we have to analyze it. So if it is commutative, then we're going to make an assumption. So if this operation is commutative, then we'll say A star B is equal to B star A. So we'll start with the left hand side. The left hand side. So what is A star B? What we're going to end up with, we're going to check if it will be the same with B star A. So we say A star B, it is actually already here. So A star B is A plus B minus AB. So this is the expression for A star B. What about on the right hand side? So there's nothing much to simplify. So we have more practice questions where things will be interesting. So the right hand side, we have B star A, meaning we start with B. While there's A, we put B. So meaning we're going to have B plus A minus B A. We have just swapped. Instead of starting with A, we have put B. Yeah, so this we can rearrange it. It will be A plus B minus BA. Oh, yeah, we can also rearrange this as AB. So you can see that the left hand side is equal to the right hand side. Therefore, yes, it is commutative. Yeah, so don't worry, we'll have more practice questions coming up just for easy understanding. So this is how you would do it. You just check when you simplify if there's need to simplify anything. Yeah, so let us look at the third one. So here we are going to have a lot to do. Is it associative? So if it is associative, then if this operation is associative, then A star B star C, it is the same as A star B star C. So we're going to work with the left hand side. So on the left hand side, let us deal with A star B, and then at the far end we'll put star C. So starting with A star B, A star B, we just follow the same order the way it is. A star B, where there's A we put A, plus where there's B we put B, minus AB. Yeah, so this is the whole function. This is the whole expression. We're done with A star B. And then we shouldn't forget that at the far end we have star C at the far end. So this was our A star B. We have now worked it out. So let's do star C. So this part is why it really gets confusing for a number of people. So remember, our operation is given as, they have told us that A star B, it is A plus B minus AB. You know, this simply means that when you have two things, the first thing will be where there's A, and then the second thing will be where there's B. Yeah. So here, what we simply have is, this is the first thing, meaning we're calling this A. This is the second thing, we'll call it B. Yeah, so where there's A, we put the whole lot of this thing. So we're going to have A plus B minus AB. The whole lot of this is just A, meaning we're just here. And then let's put B. B, it is the last part, which is C. So plus, we write our C here, plus C. Okay, and then from here we simplify. Can we add anything? So we can't really add anything. We can just arrange the letters in alphabetical order. We say A plus B plus C, and then at the far end we put AB. Yeah, so meaning this is the left hand side. So now let us calculate the right hand side and see what we get. So on the right hand side we have this. We have A star B star C. So meaning A, first we are not going to operate with A. We start with B star C. So please always remember, you just have to get this this hint. So B star C, meaning the first thing which is being mentioned is B. The last thing which is being mentioned is C, meaning wherever there is A, you put B. Wherever there is this one B, we are putting C, because we are dealing with B star C. This is just the same as saying 2 star 3. It means where there is A, you put 2. Where there is B, you put 3. But just that things can look complicating because we have letters again. So where there is A, what do we put? Where there is A, we put B. So meaning we are going to have B plus C. So here, so this is B plus C minus wherever there's A, we're putting B, and then where there's B, we're putting C. Yeah, so this will be A star B, B plus C minus BC when we multiply. So remember, we haven't yet done the operation on A. So here we're done with B star C. This is B star C. So since we're done with B star C, we can come back to A, meaning this is our first letter. It will take the form of A, and the whole lot of this is our second letter. It will take the form of B. So let me just move these guys here. So here we're just going to say this A is the first letter, meaning here. So meaning here where there's A, we're putting A because it's the first letter. And then the second letter is the whole lot of this. Meaning wherever there's B, we put that short thing. So while there's A, we put A. While there's B, we put everything here. So you are ready to proceed. So we're going to say this will be A plus B, it is this whole thing, B plus C minus BC. Yeah. And then from here there's nothing else to simplify, meaning this is just the final answer. So let's put in alphabetical order: A, B, C, and then the combinations BC. So here you can see the right hand side is not equal to the left hand side. They were both starting well, ABC, ABC, but here we have plus AB, but here we have BC, even having a minus. So this is not associative. Yeah, so that's how you prove. So take your time. You can actually just go through everything. You don't have to rush. So you can see I'm speaking very slowly so that you understand very nicely. So are you ready for another example before we end? So let's do another example. Okay, so we have that cute question. Yeah, very nice. Let star be a binary operation on integers defined by this. Can you find 4 star negative 1? Is it associative? Does it have an identity? So we start with the first one. So actually this one is very easy. You can even pause the video and then solve it on your own, and then you see what you get. Please remember that is the best way to learn. Yeah, so we want to find 4 star negative 1 star 6. So remember the function they have given us, the function is x star y, meaning x is the first thing. It is equal to xy plus 5. So just while there's x, you put the first thing. While there's y, you put the second thing there. So we start with 4 star negative 1. So we're going to say 4 star negative 1 there, and then negative 6 will just be following. We'll do it later on. Remember, binary, we just deal with 2 things only. So the first thing, so we want to find 4 star negative 1, meaning wherever there's x, we put 4. So this will be x, x, and then while there's y here, so remember this is our operation. I think I should just write it here so that we even follow it nicely. So it is xy plus 5. So while there's 4, we just put, while there's x, we put 4. I want it to be in blue. So while there's x, we put 4, and then while there's y, we put negative 1, and then plus 5. Remember, star 6 is just following. Star 6 is waiting for its opportunity when these 2 are done. So we're going to say 4 times negative 1, this is negative 4, plus 5. So this is positive 1. So 1 here, star 6 just is just following. So meaning negative 4 star negative 1, we just end up with 1 there. And then meaning let us now deal with 1 star 6. So remember the first thing, this means this is x, and this it is y. Yeah, so I hope we are very much together up to this point. So maybe let me just take this at the far end. So star 6 was just following. So when we deal with 4 star negative 1, we end up with just 1. So now let's do 1 star 6 binary operation. So they can even give you something like this: negative 2 star 5 star 3 star negative 10. Just know that you'll be doing it one by one. You deal with this, it will give you a single answer, maybe negative 3, and then you combine it with these 3. When you deal with the 2 of them, maybe it gives you like 12, and then you say star negative 10. It is a staircase, it just goes on like that. You do 2 by 2, caterpillar by 2. So we have 1, this was the final answer, 1, and then the 6 which was following, it was just waiting for its chance. So 1 star 6, remember x star y, so what we have is just xy plus 5. So here where there's the first letter here, now we have 1, the other letter is 6, meaning wherever there's x, we're putting what? 1. Wherever there's y, we're putting what? 6. And then 5 is just following. So 1 times 6 plus 5, we get 11. So that's how you solve. So we're done with the first one. And then we go to the next question. Is the operation associative? I hate associativity. Okay, so we have A star B star C. This is associative property. So we're going to start with AB and then we combine it with C. We want to check if we're going to end up with the same thing if we combine the 3 sets together, but we start with BC. Yeah, so this is the left hand side and this is the right hand side. So we start with the left hand side. So on the left hand side, we want to do A star B star C, starting with AB. So in this case, meaning while there's X, we'll be putting A, while there's Y, we put B. So meaning we're going to have A. So let me just write it for simplicity's sake. So this is the operation. So while there's A, while there's X, we put A. While there's Y, we put B. And then plus 5 here. So star C is just following this Kamalito thing. So let us simplify this part. When we're done simplifying, that's when we are going to consider C. So A times B, it is AB plus 5. Yeah, so star C is just waiting for his chance. So at this point, we cannot simplify further. There's nothing much to do. So meaning we are done with A star B. We can now consider C. So this means that this part is the first item and this part is the second item. Yeah, so let's do the needful. So we're going to just push it a little bit up. Okay, so remember the function is xy plus 5. So while there's x, we're putting this. So while there's x, we're putting AB plus 5 while there's x. And then y is this part C. This is y. And then don't forget to have a plus 5 at the far end. So this will be multiplication-ish. So AB times C, it is ABC. and then 5 times c, it is 5c, and then plus 5 here. So meaning this is the left hand side. So this is the left hand side. So now let's do the right hand side. What are we going to get? We go to the right. So the right hand side, which is there, we have a star. So this was supposed to be star. A star B star C. So we write A star. So here B star C. Remember the original thing is xy plus 5. So meaning where there's x we put B, and then where there's C we put y. So this is A star. Where there's x we put B like that. Where there's y we put C. So I have a plus 5. So from here we say A star BC, or B times C, it is BC plus 5. So there's nothing much to simplify, meaning we can now operate with A. So the first letter we're calling it X, the other part is Y. So let's simplify. We're going to have so remember, I'm rewriting the function so that we always remember what to put. So where there's x we put A. We have written A like that, and then where there's y we put BC plus 5. So here if you're not careful you can just end there and then you start going down. Remember we also have this 5 outside. Yeah, so plus 5. So A times BC, it is A BC, plus A times 5, that is 5A, and then we have a 5 at the far end. So there's nothing much to simplify here. This is the right hand side. This is the right hand side. So you just compare now. Is the left and the right the same? So we have ABC. Okay, good. We have ABC. 5C. Oh no, we have 5A. Yeah, even 5 was similar. So except for one part, this. Therefore, you conclude to say, so this should be part of your conclusion. Since the left hand side is not equal to the right hand side, then the operation star is not our friend, is not associative. Yeah, that's how you go about the thing. So the last one, as your teacher, as your tutor, I'm not going to solve it. That is your homework. You can do it on your own. I'm very sorry. I wish we could do it together. So does the set of integers have an identity element with respect to the operation E? And such questions will never miss in an exam if they bring something on binary operation. So does it have an identity? So always remember, what are the rules for an identity? We said A star E. It is the identity. So when you add anything to an identity, it should give you the same thing. If you add A to an identity, you should just get A. Yeah. So even if you swap them, you start with the identity, you operate it with A, you should still get A. Yeah. So does an identity exist here? Yes or no? So there are I'm actually going to make another separate video which is just for practice questions. So some questions will require you to say find the identity, or sometimes find the inverse. So here, for us to know whether it will have an identity, we're just going to operate, and then we make A the subject of the formula. So we're going to say A star E. Yeah, that is the E is the identity. Yeah, so let me redo this. So you can see we have said A star E is equal to A. So we're going to say A, it is the same even if we operate it on an identity. Yeah, so this, it is just what we wrote here, and you understood that part. So meaning A will be equal to A star E. Remember our operation was xy plus 5, meaning the first thing gets x. So A, where there's x we put A. Yeah, so let me just write it. So where there's x we'll be putting A, where there's y we put the next term which is E. So meaning A star E will be equal to A times E, and then we'll have A plus 5. So this means that A is equal to AE plus 5. Yeah, so in mathematics, especially for things like binary operations, you just have to keep moving, just calculate the way you know how to, and then you end up with your answer eventually. So this is where we have reached. At this point, we just make E the subject of the formula. When we make it the subject of the formula, then we have found the identity. Yeah, remember E is the identity. So let's make E the subject of the formula. Meaning we're going to have A minus 5 is equal to AE. And then to remain with E alone, we divide throughout by A, even here by A, so that this cancels with that. This means that E is equal to A minus 5 over A. So if a question says find the identity, then we could have been done at this point. So this is the identity when you just make E the subject. But here they are just asking, does the identity exist? So at this point we have to think. This symbol is integers. So integers, they are numbers which are -1, -2, 0, 1, 2. So they are all the positive and negative numbers except fractions. So integers do not include fractions. So at this point you can see E is our identity, but it is a fraction, and integers cannot be fractions. So therefore, you are going to conclude in your book, therefore E does not have the identity. You say the identity does not exist, or it doesn't have an identity. You even give a reason, because integers cannot be fractions. Yeah, so this is where we end with this lesson in binary operations. You can check out the other videos on SADS, practice questions on binary operations, functions, and everything else. And now don't forget to subscribe. So we end here. See you in the next lesson.